I hope you are doing well. This is Jennifer, Chemistry Official, where we make chemistry friendly for all our learners. This lesson is a continuation of the periodic table questions. In our previous lessons, you already had a few of them, and today we continue with question number 5, where using the periodic table that has been provided, we are going to write electronic arrangement of the stable ion formed by element L. And then from there we will be writing an equation for the reaction between element H and element P. And then finalize the lesson by naming the type of a bond that is formed when H and P react, and also when Q and K react. So let us begin together, and as usual, make sure that there is something you're doing in your notebook so that it will be very easy for you to follow on in everything that you are doing. Just to remind you, there is an NB in the question that is saying that the letters used are not the actual symbols of the elements. So any letters that you see in the periodic table that has been provided, note that these are not the actual letters. For example, in the periodic table you can already see a capital H somewhere. Capital H is known to be the symbol for hydrogen. But in our periodic table, the one that is already provided here for you, H is not hydrogen. So H is actually lithium, as we will be seeing later. So always remember, when you're provided with such a periodic table, the first thing is for you to fill in the atomic numbers, because through the filling of the atomic numbers in the spaces provided in the periodic table, you are able to know which element you are actually dealing with. So even before we go to any question, remember there is that backup information that you should always have, and first of all write it on the grid. I told you the word grid is here to represent the part of the periodic table that is already provided for you. So let us begin indicating the atomic number. We begin with 1 there. We go to the other side where we have 2. We come back here with 3, then 4, we omit this space, we go to 5, then to 6, then to 7, to 8, to 9, to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Last time I told you that the space that is in between here, the shaded part, usually comprise of 10 columns, the vertical columns. So by the time you are coming from this 20 and going to this next space over here, you will add to the 20 10, because now this space is divided into 10, and this is a whole period from where we have M to the end, and so the atomic numbers should follow one another. So this is not 21, it will be that one. Now that we have 20 plus the 10 spaces in here, then this one will be that 1, that 2, that 3, that 4, that 5, and then 36. So that is one of the backup information that you should be in a position to interpret yourself, so that anything else that you'll be doing in the questions will be very easy for you. So we go on with the question now. We are being told that we are supposed to write the electronic arrangement of the stable ion. The stable ion, that is where the key thing is that should guide you in the question. So in actual sense, you are being required to write the ionic configuration. That is the configuration of the ion that will be formed once L react. So to begin with, you must know whether L is a metal or if it is a non-metal. Let me remind you of something. In our previous lessons, we already said that elements in group 1 Group 2 and group 3 are usually metals. Group 4 are metalloids. Then we have group 5, group 6, and group 7. They are usually nonmetals. So that is another part of the backup information that you should be having. Then from there you say that whenever you have metals, they react by losing electrons from the outermost energy level. Whenever you have metalloids, they can lose and they can also gain, now that they are in between. For the nonmetals, they react by gaining. So once you know that backup information as well, you are able to continue with the question. From there, after you have known that information, there is something else that you need to indicate on the grid that is provided, the periodic table that is provided for you here. So you are supposed to come up here, starting from this side, and then you indicate the number of the group. We have group 1 there, group 2, group 3, group 4, group 5, group 6, group 7, and then group 8 is on top there. And just again, again, I want to remind you that whenever you are writing the groups, you should always use Roman numbers. Roman numbers. Then, down here on the side, you are supposed to indicate the number of the periods, and there you can use the normal natural number. So you have period 1 that runs across this direction. So this element on top here and this other one are the ones that are in period 1. Period 2 has these two. You jump the space here, you continue. This is also period 2. Then we have period 3 that has these two. You jump the space, you continue with it to the end. And then period 4 is a continuation, as I have just shown you. So, but for the periods, you can use the natural numbers 1, 2, 3, 4, the normal way we write them. But for the groups, it is strictly by the use of Roman numbers. So we go back to the question. The ion that you are required to write about is L. L is atomic number 13. Then from it we write the electronic arrangement for the atom of L. And these three in the outermost energy level, because this is the first energy level, the second and the third, the outermost energy level has 3. This is an indicator that L is a metal in group 3, and metals in group 3 react by losing the 3 electrons in the outermost energy level, meaning after it has lost the 3 electrons in the outermost energy level, also the outermost energy level will also be lost together with the electrons. So it will remain with an ionic configuration of 2.8, and this is the answer. So it is either the question is requiring you to write the electronic arrangement for the stable ion, or they go direct and tell you to write the ionic configuration. So the other name of electronic arrangement for the ion, for the stable ion, is ionic configuration. Ionic configuration. So whatever was required in the question was the ionic configuration, or rather the electronic arrangement for the stable ion. Stable ion meaning after L has lost the 3 electrons from the outermost energy level. So this is the answer, 2.8. So the next question, number 6, is telling us to write an equation for the reaction between H and P. Note that even though the question is not specific to what kind of an equation is required to be written, you should note that whenever such a question is provided, a chemical equation is the one that is needed. A chemical equation meaning that it is the equation that uses chemical symbols and not the one that is using the words, or rather the names of the elements. So, and again, anytime you are given such a question to write an equation, remember that the letters that are provided in the periodic table are the ones that are supposed to be used. Like now, from the grid or the periodic table provided, we have element H. Normally, element H stands for hydrogen, but in our periodic table here, H is not hydrogen. It is actually lithium, because as we wrote from the beginning, this is atomic number 3. So H is lithium. H is lithium and not hydrogen. Remember whatever is in the bracket here, this and B, in the question that is saying that the letters used are not the actual symbols. So always remember that. Even when letters are used and you know those letters, what they represent in a normal situation, remember they are just there to represent other elements. Right now, for another example, is this K. Among the first 20 elements, K represent potassium. But from the atomic number, K is atomic number 8. So K is just a letter representing oxygen, because oxygen is the one that is atomic number 8. Look at this other one, P, capital P. In a normal situation, P is for phosphorus, but in here, this is a halogen, and phosphorus is not a halogen, because the P that we have here is in group 7, meaning it is a halogen, a group 7 element. And a P for phosphorus, it is supposed to be for group 5. So P is just there to represent a certain element that is in group 7. Look at this other one, N, capital N. Capital N normally is for nitrogen, and nitrogen is in group 5, and in whatever N that is provided in here is in group 4. Nitrogen cannot be in group 4 normally, so if it were to be nitrogen, then it could have been on top here where we have atomic number 7. So do not confuse the letters that are provided for you to use and the real symbols. That is why anytime you're given such a question, there is usually a disclaimer or some information into bracket or written as an NB, that the letters that are provided for you there are just there to represent, and they are not the actual symbols for the elements. So H and P. Even when you are required to write a chemical equation using chemical symbols, and even when the real elements are not the ones that should appear in the equation, you should, in the back of your mind, try to ask yourself what H is in the real situation and what P could be in the real situation. So let us begin with H. We have just said that from the atomic number 3, H is lithium. So it is a metal. It is a metal. Metal in group what? In group 1. So meaning the valency should be 1. How have you determined the valency? From the fact that it is in group 1, even without the atomic number, actually, you can just know that any element in group 1 has a valency of 1. Any element in group 2 has a valency of 2. Any element in group 3 has a valency of 3. Any element in group 4 has a valency of 4. When we go to the side of from group 5 to group 7, you determine how many electrons it will be gaining. So elements in group 5, because they have 5 electrons in the outermost energy level, meaning they require to gain 3 to attain an octet configuration. I mean to attain a maximum of 8 electrons in the outermost energy level. From the 5 that they have in the outermost energy level, they will be required to gain 3. So 3 is the valency. In group 6, they are required to gain 2. Because they have 6 electrons in the outermost energy level, they are required to gain 2 to attain the stable configuration of 8. So for group 7, they need to gain 1. So they have valence 1. Group 6 have valence 2. Group 5 have valence 3. So you understand? So meaning that H from the group that it is pressed, it is already with a valence 1, meaning it is a metal. Then for P, even though from the first 20 elements we don't study P, so you should not like have fear that P was not taught among the first 20 elements. You should be happy that it is already placed in group 7 and you already can predict the valence for group 7 because like now among the first 20 elements we learn more about atomic number 9, which is fluorine, and atomic number 17, which is chlorine, but we don't mention the rest very much. We don't mention them very much among the 20 elements because those ones are beyond the 20, the atomic number 20. But even then, the fact that it is placed in group 7 is enough clue to tell you what valence it has. It has valence 1. And just that little information is enough for you to write the correct formula for the compound that will be formed. So again, remember that even though the kind of an equation that is required here, I said, is a chemical equation, you must write a word equation somewhere else using the real identity of those elements so that you are able to predict what kind of an equation you will write. So we first of all write the word equation. We already said that H is lithium with atomic number 3. So we write the word lithium here. Then the identity of P is bromine. So we write bromine there. What kind of a compound is formed when a metal reacts with a halogen? The answer is whenever a metal reacts with a halogen, we get a metal halide. So like in this case, lithium plus bromine, we get lithium bromide. Lithium bromide. In terms of the chemical equation, lithium is written like that. It is in the solid state. Bromine is usually a diatomic gas. And then for lithium bromide, we say lithium is in group 1 with a valence 1. Bromine is in group 7 again with a valence 1. Then we exchange them. So we get lithium with the valence 1 from the one that is from bromine, and then bromine takes the one that was from lithium, and then you cancel them out. So lithium bromide is written like that. So that is actually the one that we will be writing as the product. So now that we have the real equation, and remembering that for such an equation we said that only letters are supposed to be used, then we come back to the letters and we say lithium was standing in for H. Then P was standing in for bromine. So we come here starting with lithium. So we are now like wherever we have lithium, we write capital H because lithium is represented by capital H in the periodic table provided. So we write capital H for lithium. It is a metal and it is in the solid state. Then P is being represented by, P is for bromine. So we write P. And remember, P is a diatomic gas because P is representing bromine, Br, so that is the P, and it has a 2 there, so the 2 must be here also. It is a gas. And then the formula for lithium bromide is LiBr. Wherever we have Li, we remember that is H. capital H, and wherever we have BR, that is P. So it will be H and P, and it is in the solid state. So I hope I have made it easier for you. So let me repeat the procedure that you are using. The question is asking you to write a chemical equation, to write an equation. But back in your mind, you know, though it is just talking of an equation, it is actually requiring you to write a chemical equation using the chemical symbols. For you to be in a position to write a chemical equation, you must first of all know how to write a word equation. The other thing is, the letters that have been provided in the question are the ones that you're supposed to use when you're writing the chemical equation. But for you to be in a position to know how they are reacting, you must back in your mind know the real elements that they represent. So you write a word equation using the real elements that they represent. Once you write the real chemical equation using the real elements, and then from the word equation using the real elements, you write the real chemical equation using the real elements. Then you come replacing the real elements with the letters that have been provided. And of course, being a chemical equation, we must balance it. Before we balance it, I want to tell you something here. Anytime you are told to write such an equation, and there is this product that will be formed here, some of the students make a mistake and they write it like this one, which is lithium bromide. They start with the P and then L. It will be wrong, because whenever you are writing a formula for a compound, always remember that the metal comes first, or rather the metal is written on the left hand side of the formula, while the non-metal is written on the right hand side of the formula. So it cannot be H, it cannot be pH, it cannot be pH, not PL, it cannot be pH. Yani you cannot start with P and then H. It can only be HP, because H is the metal and P is the one that is the non-metal. So then from there we balance the equation, because a chemical equation must be balanced. So let me show you how we are supposed to balance it. So this is the equation. We have H S in the solid state plus P2 in the gaseous state to give us HP in the solid state. Let us start balancing. When you look at H, it is 1 on this side, and on the other side it is also 1. So H is already balanced. Then we go down to P. There are 2, and on the product side P is 1. So we need to make P become 2. And the only way that we can make P become 2 like the reactant side is by multiplying this one by 2. So these 2 that we multiply with, we write it behind there. So that it can become 2, and we say it is now balanced. So the P's are now balanced. If you leave it at that, it will be wrong. Why? Because while you are balancing the P, you ended up unbalancing the H that was initially balanced. Look here, H was 1 initially, and it was also 1 on the other side. But as you are balancing the P, for P to become 2, H has now become 2. So you must go back here and balance the H. So H is no longer balanced. So you must again multiply it with 2, and then these 2 you indicate it behind there. for it to become 2, and so that it can be well balanced. So you come back to this equation and you make sure that you write the 2 there and also another 2 behind here. You write another 2 behind there so that it can be well balanced. So this is now the equation that we are needed to write. So don't just go jumping to the writing of the chemical equation without first of all considering what elements they are. You write a word equation using the real elements. From the word equation you write a chemical equation, then you transfer. Wherever you had lithium, you write H. Wherever you had bromine, you write P. And then you leave it at that after you have balanced it, and it will be very okay. Question 7. Name the type of bond formed when H and P react. So actually that is what we had in question 6. When H and P react, we end up with an ionic bond. Why an ionic bond? It's because H is a metal, P is a non-metal, and ionic bond is that bond that is formed between metals and non-metals, because metals react by losing electrons, while non-metals react by gaining electrons. So the electrons that will have been lost by the metal, in this case the H, are the same electrons that will be gained by P. So there will be transfer of electrons from the metal to the non-metal. So that is ionic bond. For Q and K, Q is in group 4. This is carbon. As a real element, Q is standing in for carbon because it is atomic number 6. Carbon, we said last time, is a metalloid. So whenever it will be combining with K which is here, which is oxygen, K which is in group 6 because it is oxygen. Oxygen in group 6 is a nonmetal. Carbon is a metalloid. Whenever these two will be combining, the kind of bond that will be formed is a covalent bond. It is a covalent bond because both of them will be combining as nonmetals. And the reason as to why they will form a covalent bond, it is because the bond will involve sharing of electrons. There will be sharing of electrons between carbon and oxygen. That is K, which is representing oxygen, and Q, that is representing carbon. So those are the answers to those questions that we have. I'll be preparing more and more questions on the same periodic table, and I hope by now you have a clue on how questions should be tackled in this area. And if you never knew, the periodic table knowledge is actually a foundation to so many areas in chemistry. Any student who has enough knowledge on the periodic table has an easy time understanding any other area of chemistry in the chemistry syllabus, because it is in this subtopic of the periodic table that you're able to know about the valences, to know about the groups, the periods, the writing of the equations, so many things. And once you know them, it will be a walkover whenever you be tackling questions in other areas of the syllabus. So make sure that you are understanding something, and in case of any area of difficulty, feel free to ask it in the comment section. I would feel very nice interacting with you in the comment section. So make sure that you're writing something. Have you understood? Where did you find any difficulty understanding? I'll gladly explain more. So I'm wishing you the very best. To the new subscribers, welcome home. This is where chemistry is made very friendly for all of us. For the returning subscribers, thank you very much. You consider this channel to be a part of your life. So thank you very much. Tell a friend to tell a friend. Let us all gather here to make chemistry friendly to all our learners wherever they are. So I'm wishing you the very best as you continue revising. May it be well with you. Thank you very much.